All right, so the quiz, as agreed, the quiz will be open right after the class, right? It's all on chapter 4. It's going to be all on chapter 4. So today we're going to start chapter 5. Okay.
How long will it be open for?
Yeah, it's like, it's going to be due Thursday noon for the submission.
Okay.
Thursday noon. Not 11:59 p.m. like some people assume it's going to be always 59 p.m. It's only Thursday noon. Okay, so we're going to start chapter 5, which is about, functions, basically. So let me go ahead. So, and then I'm going to go ahead and share my screen. Hopefully, okay. So everybody can see my screen?
Yeah.
Okay, thank you. So
Yes.
chapter 5 is functions. So we're going to introduce in 5.1 what is a function, etc., right? But we're going to start with introducing what we call a relation. So what is a relation? A relation is any set of ordered pairs XY. Excuse me, guys. Hello? 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 Yes, this is Dr. Ao. Okay, so it's any set of ordered pairs XY is called a relation. Okay, so there is no further conditions. If you say, for instance, example, if you say like 1, -2, 2, 0, 1, 2, 2, 1, right? And then 0, 3. That is an example of a relation. This set of ordered pairs is called a relation. There is no. Hello? Can you stop calling me, please? I'm in my class, please. Yeah, some people are crazy. All right, so this is a relation. I don't know who is playing with my phone, I hear some people laughing, they're just playing with me. So what is a domain? What you call the domain here is the set of the X values. Set of the X values. This is what you call the domain, the set of the X values. So in this case, what's going to be the domain here? What are the x values here? The first numbers is 1, 2. You see, we don't have to repeat the 1. We don't have to repeat the 1 here. Okay, let me change this one, 3, 1. I change this one to 3. 1, 2. I have another one, but I don't have to write it twice, right? And then 3, and then 0. And also, they don't have to be listed in order. Every time you put braces right here, you don't have to list in order, right? You don't have to. When you put braces, you don't have to list them in order, all right? So that is the domain. That is what we call the domain, is a set of all the x values. Everybody see that? You see, if you are given a relation and we ask you what is the domain, don't forget that. These are some very, very simple questions to answer to. These are the set of the x values. What do we call the range? The range is the set of the y values. This is what you call the range. So tell me then, for this example, what's going to be the range then? What is the first y value that we see?
-2.
-2, and then?
0.
And then?
2. 1.
And
3.
And 3. This is a range. The domain is that, the range is that. As simple as that. Okay? That is the relation. There is no further condition on the relation. There is no further condition. Any set of ordered pairs is called a relation. You see? So now we can represent the relation this way. This is one representation. We can represent it another way. So we can also represent a relation using what you call an arrow diagram. Arrow diagram. Which means we're going to put right here, I'm going to put 2 sets like this, right? And another set like this. The first set will be the domain. This is going to be the range, right? I'm going to put the numbers in the domain 1, 2, 3, 0. The numbers in the range, -2, 0, 2, 1, 3. And then I'm going to represent with an arrow every pair. For instance, the first one is 1, -2. So I put 1, -2. The second one is 2, 0. I put 2, 0. The third one is 1, 2. I put 1, 2 like this, right? The third one is 3, 1, right? I put 3, 1 like this. And the last one is 0, 3. I put 0, 3 like this. That is another representation, right? Of course, you know, all these representations, they are practical only if you don't have like lots of pairs. Imagine you have a relation where you have 100 pairs, right? It's going to be like, it's going to take you a long time to represent. It's going to take you a long time to represent 100 pairs, right? This is only practical if you have a finite number, a small number of pairs, right? If you have like 200 of them, you know, imagine yourself like you know, writing 200 stuff, 200, you know, pairs, okay? Another way to represent a relation, is through a graph, right? We can also graph it. So we can also graph the representation, okay? So we can also graph it. A graph, right? So you all know the graph will have this. We have this, right? This is the x-axis. This is the y-axis. And then we put the units 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? 1, 2, etc. So this graph right here, this relation, the graph of this relation will be about how many points? How many points will represent this graph, this relation? How many? 5
About
points,
5.
right? Exactly, only 5 points. So a graph is a collection of points. They don't have to be like billions of points. 1 point can represent a graph, 2 points can represent graphs, 3 points, etc., etc. So the first point is 1, -2. The first point is 1, -2, is 1, -2 here. I have 1, is this one right here. The second point is 1, 2. There are 1, 2 here. And then we have 2, 0. 2, 0 is here. And then we have 3, 1. 3, 1 is here. And then we have 0, 3. 0, 3 is here. So the collection of these 5 points represent also my relation. This is a relation. So we can represent relation a lot of ways. We can represent it graphically. We can do the arrow diagram, or we can just go ahead and list all the points, right? But again, this is only practical if you have like a reasonable number of points. So now, what do we call a function now? A function is a relation that verifies a certain condition. You see a relation here, in our daily life, we can use a relation a lot. Every time you map two sets together, you have a relation. There is no condition. There is nothing that we ask. But for the function is completely mathematical. We almost use function only in math. I don't think in our daily lives we use a function a lot because it's a technical. It is some type of technical term. So for instance, when I say this relation right here is not a function, this relation right here is not a function. Some of you, do you know why this relation is not a function? Just by chance, do you happen to know that? Why? What would be the reason?
It fails the vertical line test. There can be 2 y's at the same x.
Thank you very much. Exactly. This is exactly the reason. This relation is not a function because we have 1x. Can you, for instance, this 1x right here, this one, how many y's this x is associated to? 2 different y's, right? That every time we have that case, if you have 1x for several y's, then it is not a function anymore. Okay? If you have 1x for several y's, then that is not a function. So meaning this x right here is associated to these 2 y's, you see? So we have 2 arrows diverging from the same x. Every time that happens, then we say not a function. Okay? So a function is a relation where every x in the domain, a relation where each x in the domain is assigned to exactly 1 y. To exactly 1 y in the range. 1 y in the range, right? That is what you call a function. Each x in the domain is assigned to exactly 1 y in the range. If you find more than one y in the range, then it's not a function anymore. Okay, so for instance, if you put all of you in one set, right? You put all the students in this class in one set. You put it right here. All of you students here. And here's the grade, your final grade you will have in this class. You see student number 1, student number 2, student number 3, etc. And here you have A, B, C, and F. These are the four possible grades in this class, right? At the end of the class. Will that be a function or not? What do you think? Will that be a function or not?
I mean, only if there were 4 different students who got 4 different grades. Anything else, it wouldn't be a function.
I mean, if you have like, let's say you have like, your class has 20 students, right? This way, do you think it's going to be a function or not?
No.
No? Every student will have how many grades? I'm talking about final grade. Every student will have how many final grades? Only? Every student will have only one final grade, right?
Yeah, but there's not enough different kinds of grades for each student. You have to use.
That's a good point, but it does not prevent it to be a function. All of you can have the same grade. As long as every one of you has only one grade, that is a function. You see?
Oh, I see. The grade is
The range. The grade is a range. To decide if something is a function or not, we focus more on the domain, right? Every x has how many y's? We almost don't care on every y has how many x's. We don't care about that. You see, the whole class can score A. I mean, I wish it's going to be the case, you know. If the whole class has an A, it's going to be a function, okay? So that will be a function. When it's going to fail to be a function now, if we put the grades as a domain now, and we put the students as a range, this likely will not be a function because at least 2 students will share the same, hello?
same grade.
Hello? Hello? Can you stop calling me? I'm in my class, doing my class. Please. It's annoying. Okay, so when you have this case right here, very likely your class has more than four students, right? Very likely 2 of you will share the same grade, right? In that case, this will not be a function because very likely if you have this, if you have more than 4 students, you have student number 1, number 2, number 3, number 4, number 5. If you have 5 students, at least 2 of you will share the same grade, right? At least. So that will not be a function. So in this case, it's going to be a function. In this case, it won't be a function. So now, if you go graphically now, look at graphically, and this is what KT talk about, or Destiny. So graphically, if you look at this vertical line right here, how many times the vertical line, this blue vertical line, how many times it intersects with the graph? How many times?
Twice.
Twice. Every time that happens, we say that the graph does not represent a function. We call that the vertical line test. Okay? The vertical line test is a very simple test. If you have one vertical line that intersects with the graph more than one time, then that graph does not represent a function. Okay? We call that the vertical line test. If your relation is represented by a graph, to see if this represents a function or not, you just graph it. I mean, you just see if there is a vertical line that hits the graph more than one time. So the vertical line test right? So a graph represents a function. A graph represents a function if no vertical line meets the graph more than once. No vertical line meets it more than once. Okay. In that case, if it just meets the graph, if all vertical lines meet the graph only one time to the most, then we say it represents a function. For instance, right here, this graph right here, which is a straight line like this graph right here, does it represent a function or not? Does it pass the vertical line test?
Yes.
Yes.
It does, right? There is no vertical line that will meet this graph more than one time, right? So we say passes this, yes, it represents a function. A function. Okay, so this graph right here, this graph right here, what do you think? Does it represent a vertical line? I mean, does it represent a function, or yes or no?
Also yes.
Also yes, right? Also, this one is also a function. All right. Now, if I give you now this graph right here, this graph right here, what do you think? Does this represent a function?
No.
It does not. For this graph, it's very easy to find vertical line. For instance, this vertical line, right, meets the graph here and here 2 times. No, it's not a function. What type of shape? What type of shape will never represent a function? Can you give me an example of shapes that will never represent functions? For instance,
The
A
one
circle?
you just did, a U on its side.
yeah, a circle, right? You see, circle, any closed graph has no chance to represent a function, right? If the graph is closed, it has no chance to represent a function, all right? So that is a vertical line test. Now, imagine in any test right here or final exam, we ask you a question like, we give you a graph and we ask you, is it a function or not? Will that question will be easy? What do you think?
Relatively, yes.
I think that question will be easy if we heard about the vertical line test, right? If you heard about it, that question should be easy. Okay? So that is the vertical line test. Now, there is another way to represent a function, right? Which is our preferred way to represent a function, which is the algebraic way. So let me give you this example, this function right here. 2, 3, -1, 5. Let's say 5, 6, 2, 8, right? Say this. Right? This is my relation right here. And I call it F. This relation, I label it, I call it F. F is the rule of assignment. Do you see any pattern of assignment here, or is it just random for you? Do you see any pattern of assignment? Do you see any logic?
Add
They're
3.
both
Add
very-
how much?
3.
Exactly. Looks like every number is assigned to itself plus 3, right? What is 2 plus 3? 5. What is 3 plus 3? 6. Negative 1 plus 3, 2. 5 plus 3 is 8. It does look like each number is assigned to itself plus 3, plus 5, right? So by the way, is that a function or not? Is that a function or not?
Yes.
It is a function, right? Because every x is assigned to only exactly one y. So how we represent that? We say f, the domain is 2, 3, negative 1, 5. The range is 5, 6, 2, 8. You see, if I want to represent this, the first arrow can be represented this way. F of 2 is equal 5. Everybody see that? This is not a multiplication. The parentheses do not represent a multiplication. They just say 2 is assigned to 5. That's it. F of 2 is 5. Okay? That how we read this? We read F of 2 is 5. Okay? This is how we read it. So any number between the parentheses is read as an x value. Any number on the other side is read as a y value. Okay? Any number between the parentheses is read as an x value. The other number is read as a y value. So we say 5 is the image of 2 under F. Okay? This is how we read this. 5 is the image of 2 under F. How are you going to read? How are you going to write the third arrow? You're going to write F of what equal what? The third arrow. F of
3 equals 6.
That's the second arrow, right? F of the third arrow tells you F of
3 equals 6.
no, that's the second arrow. The third arrow is this one right here.
Oh, third, sorry.
Yeah, F of negative 1 is equal to
2.
2, right? F of 5 is equal to 8, right? Etc. etc. So now look now. If x was here, and I want to follow the same logic of assignment, I would assign x to what?
Y.
I would. You see,
X
look,
plus 5.
x plus not plus 5, but x plus how much?
3.
We say
3.
x plus 3, right?
Oh.
I would assign, if I want to follow the same pattern of assignment, I would assign x to x plus 3, right? So I write f of x is what? Is x plus 3. That is the algebraic representation. That is algebraic representation. This representation is the best one. Why? Because in this representation, we don't have to enumerate anything. Okay? We don't have to enumerate anything. That is the best representation if you want to do calculations, right? You see, the arrow diagram is only practical if you have like a small number of arrows, right? You cannot represent something that has 1,000 arrows. Nobody has a time to do 1,000 arrows. No time, no space, right, for that. So the best representation of a function, if it is a numerical function, is to the algebraic representation. F of x equals something. And that f of x is a y value. F of x is always a y, see? Okay, so now if you have f of x equal x plus 3, now if I ask you what is f of 9, what you going to do? If f of x is given as f of x is x plus 3, somebody asks you what is f of 9, you're going to substitute x with 9, right? You're going to say it's 9 plus what? 9 plus 3. So basically, every time you are given f of x, if he asks you what is the f of somebody, everywhere you see x, you substitute that number. It's going to be 12. If he asks you what is the f of negative 6, what you do? You substitute x with negative 6. It will be negative 6 plus 3. You see, the plus 3 doesn't change. The only stuff I change is the x, right? The only thing I change is x. It's going to be, negative 3 here. Even if I don't know, for instance, f of this, for instance, do I even know what this stuff is? How we call this stuff? even if I don't know, right? Let's assume I don't know what this rectangle is. I don't need to know what this rectangle is. What I do? I'm still going to substitute the x with what? With a rectangle, right? You see? That's what you call the plug-in. You plug in whatever you have between the parentheses. Every time you see the variable x, the input variable x, you remove the x and you put whatever you have inside the parentheses. Okay? It doesn't matter if you know what they are or if you don't know what they are. That's what you call evaluating a function. This is what you're going to learn right now through examples. Evaluating a function. So let's say f of x equals 5x squared minus 4x minus 7, right? And somebody asked me to find f of three. What I do? If you ask me to find f of 3, what I do? Everywhere I see x, what I put?
3.
I put. Everything else is kept unchanged. Only the x will change to 3. Only the x changes to 3. Everybody else, everything else, you see the 5 doesn't change, right? But the 3, I change 3 here, and the square is left unchanged also. Minus 4 times what? Times 3, right? And then minus 7. You see? That is the substitution part. That part, I think that part must be easy because it's just a substitution. You just substitute. Whatever you have between the parentheses, you don't multiply again. The f of 3, this is not a multiplication. It's not f times 3. Not a multiplication. It means f of 3, right? So everywhere you see x, you substitute 3, and then you do the math. When you do the math, you have to respect the PEMDAS, right? The order of operations. You see 3 squared is 9. 5 times 9 is 45. Minus 12 minus 7 is 45 minus 19 is 26. Okay? Everybody see that? So now I want everybody to do f of negative 2. Go ahead. How much is f of negative 2?
-2 plus what? All these.
I'm gonna let you everybody like a couple of minutes or 1 minute to everybody do the substitution and do the calculation and see what number you get at the end. So we're gonna compare our answers. All right, f of negative 2, we understand we need to plug in negative 2 everywhere, right? We understand that. So now what is the way we're gonna do it? So we're gonna substitute, we're gonna replace, right, the x squared with negative 2. So now it's gonna be negative 2 squared, right? Okay, so what am I missing? What am I missing? Can somebody tell me what I'm missing here? Before I continue, before I go any further, can you tell me what I am missing here?
Oh, the
Square.
square. That was parentheses.
Parentheses. Now, how many of you wrote this stuff without parentheses? Be honest. If you don't put parentheses, your answer, your writing is wrong. Every time you raise a negative number to any power, especially even powers, don't forget the parentheses, right? Do not forget the parentheses. This right here, I cannot forget the negative like this.
So
And
you
then
only use
minus,
a parentheses because it's negative, because you didn't use a parentheses.
yes, it is, you know, if you put negative 2 square, or you put negative 2 square, these are two different numbers, right? The negative 2 square with parentheses gives you 4. The negative 2 square without parentheses gives you negative 4.
But is
Right?
it wrong?
I don't
Is it
know.
wrong?
I thought
Like
it would
if
be.
when I did the 3, I used parentheses.
The 3, yeah. Just a good habit. Whether
Okay.
positive or negative, you can put parentheses. That's a good
So
habit.
it's not wrong to use it. Okay.
No, it's not wrong. But especially for negative numbers, if you don't use it, it becomes wrong.
Wait, so I don't know the difference. And I know this is past what we're doing, but
Yeah, the difference is negative 2 all square. When you put parentheses around the negative 2, you are multiplying negative 2 by itself. You are doing negative 2 times negative 2, right? Which end up to be positive 4. But when you do this, when you write negative 2 squared, this negative is not in the square, right? And when you follow the PEMDAS, when you follow the PEMDAS, what you're going to do first? We're going to do the exponent, right?
you follow the what?
PEMDAS, parentheses, exponent, multiplication, division, etc., right? The acronym. This is the order of operations, okay?
Oh.
We always put parentheses first, and then exponent, and then the multiplication, division, and then addition, subtraction, right? So if you follow the order of operations, you have to do 2 square first. How much is 2 square? Is 4, right?
Yeah.
And then you put the negative after. It's going to be negative 4. You see, the two outcomes are different, right?
Okay.
Unfortunately, a lot of students, they don't give a lot of importance to the parentheses in math. Parentheses are very important in math. They really change everything. You know, you forget parentheses, you get something else. Okay. So minus 4 times negative 2. 4 times negative 2. Okay. And then minus 7. Okay. And then we do the math. You see here, because I have put the parentheses, this is 4. 5 times 4 is 20, plus 8, minus 7, which is 21, right? Okay, so I'm going to give you another one here. I'm going to ask everybody to do a couple of calculations. F of x equals all right, go ahead. I let you, like, you know, some good couple of minutes. Everybody try to do that, you know, and see how much this is right, f of 0. Try to do these 3 operations and see how much you get. All right. So f of 5, right? Who's going to tell us the final answer they got? F of 5.
I can.
Go ahead,
I'm
please.
not sure if I did this one right because of the negative x, but I'll say what I did. I did negative x. I'm sorry. I did a negative, and then I put a 5 in parentheses. And then negative 3 and the 5 in I squared the 5. Sorry.
And then
negative 3 with 5 in parentheses. Plus 9.
Okay. That's
So 5,
correct. Exactly.
So 5 squared is 25. And I kept the negative.
Yep.
And
That is
then
absolutely right.
15. Then plus 9.
Which is
negative 31.
Negative 31. That is correct.
Okay. I was not sure about that.
Yeah, that is absolutely correct. The second one, f of negative 1. Somebody else.
I'll do it.
Go ahead, please.
The negative 1 in parentheses squared minus 3 with negative 1 in parentheses.
So hold on. Have you put this negative or you don't put it?
Oh sheesh. Yeah.
You see, that negative will be here. That negative, whatever we do with the x, that negative at first will be here.
Yeah.
Right? Okay. And then minus 3 times
negative 1.
Yep. And then plus
9.
Exactly.
So negative 1 squared is 1, but then the negative goes in front of it. So it's negative 1. Negative 1 plus 3 plus 9.
Yep. Which is
11.
11. Thank you very much. Thank you. And then the last one, of course, is going to be negative 0 squared minus 3 times 0 plus 9, this don't count, it's going to be 9, okay? So you see, if somebody asks you to do, for instance, whatever they ask you to do, f of a plus h,
F off.
you see,
Oh, oops.
f of a plus h, for instance, at least the first step, I'm not saying this is going to be easy to do from the beginning to the end, but the first step is an easy step, because in the first step, you just substitute whatever you see x, wherever you see x, you substitute with a plus h, and you put parentheses, right? The first step. So for instance, it's going to be negative, I put a plus h squared, right? Minus 3 parentheses a plus h, and then plus 9. You see? That substitution step should always be an easy step. And then when you have to simplify it, you go ahead, you simplify it, etc., etc. But that step should be an easy step. That is evaluating a function. All right? That is evaluating a function. So now, after that, we learned how to evaluate a function. You see, we just got a few examples, but it doesn't matter how the function look like. If you understand the rule of substitution, it doesn't matter how my function looks like. I just go ahead and substitute. After that, now we're gonna try to identify the domain and the range from a graph. Okay, we're gonna try to identify domain and range from a given graph. Okay, we know if you have given the function like this, you see, the domain is very easy to tell, right? And the range is very easy to tell. Okay, if my function is given like this, but that will not be the case. My function will be given very likely as an expression or maybe as a graph. So we're going to see how to identify the domain and the range from the graph. Finding domain and range from a graph. But first, let's try to agree on something. Every time you see a graph like this, for instance, when you see this, it means my graph stops here. My graph ends here. You see? I mean, my graph starts from here. We always go from left to right. And this point is included. When you see a closed circle, right? When you see something like that, it means my graph stops here again, but this point is not included. Okay? That is some convention we're going to take here. When you see a dot, a bolded point, a bold point, it means my graph doesn't go any further and the last point is included. If you see an open circle, it means my graph doesn't go any further, but the last point is not included. But I see that that is a convention. That is a convention we have from the graphs. Now, if you don't see nothing, or you see an arrow, it means my graph goes forever. If you see something like that, you don't see nothing, or you see an arrow like this, it means my graph does not end. Okay? Whether you see an arrow or you don't, even if you don't see nothing, if you see this, it means your graph does not end. Okay? We agree on that? When you see arrows or you don't see nothing, it means your graph has no end to it. So for instance, just to ask you this question, this right here, and this right here. What is longer? Which graph is longer?
The second one, because it doesn't end, even though the line is shorter.
Thank you very much. The second one is longer because it does not end. The other one, you know, even if we think it is the other one is longer, the other one is just a segment, right? What you call a segment of line. It has a beginning, it has an end, right? But the last one here, this small line here, does not end, okay? It just go forever. All right, so now that we know that, we're gonna see how to read the domain and the range from a graph. You see, what is the domain? The domain is the set of all x's. The domain is a set of all x values, right? If xy is in the graph, right? All x values such that xy is in the graph. The range is a set of all y values, such that xy is in the graph, right? So the domain has to be read on the x-axis. So y has to be, the range has to be read on the y-axis. The domain is on the x-axis, the y is on the y-axis. So now let me go ahead and share my screen. I have to go and get the textbook first. And I'm going to share my screen.
Dr. Au, do you teach statistics?
153? No, I never taught 153 actually. I have to begin teaching it. I never been assigned a 153 class. I have taught like all the classes. Actually, I have taught, if I think about it, I have taught all the classes except that one. I have to start teaching it. Maybe it is fun to teach statistics, right? I have to start teaching it.
Yes, we agree.
But I never been assigned that class. I think, you know, for the next semesters, maybe not this spring, but for the next one, I will ask to teach one class of statistics, just to see.
I'm still trying to figure out what math classes I'm gonna take because I haven't even declared a major yet. I don't know what I'm doing. I'm just winging it.
So did you see what they call the pathways? The pathways, you know, if according to what you want to accomplish at the end, what type of pathway you have to follow?
Yeah, I'm planning to go into biology. I'm just unsure
Okay.
of what maths I'm gonna have to take.
Yeah. After O83, I know if you want to go like through like some science pathway, I think you will have to not like, it's not, maybe not a must, but very likely you will have to do 163, which is pre-calc. You know, very likely. You know, if your path has to include calculus, then you will have to take 163, which is pre-calculus.
Yeah, except I already took a pre-calc and a calc in high school.
Okay. So if those are validated, then yeah.
Yeah, I'd have to dig up my academic transcript. I hate paperwork.
All right. So okay. So right here, you see that is the function right here, right? Everybody see my screen? This is the function right here. So this right here is a function. You see, the blue stuff is a function. So now let me go ahead and copy it so I can write on top of it. Okay. Screen skipping. So okay, let me take this. All right. Okay, right here. The blue graph is our function. Of course, it does pass the vertical line test, right? So look, my function has a starting point, right? We always read from left to right. My function start at what point? Start at what point? What are the coordinates of that point?
-5, 5.
Exactly. My function start at the point -5, 5, which is the blue dot here, this one. My function, does it end somewhere?
No.
My function does not end because of the arrow, right? My function starts from somewhere, but does not end. If somebody asks you what is a domain, you're gonna see what part of the x-axis, my function, my graph does cover. If my graph is in an umbrella, right? If my graph is in an umbrella and it is raining from above and from below, what part of the x-axis will not be wet? You see? What part of the x-axis will be covered by my graph? That is a domain. To know that, you start from the left and you go until where the graph ends to the right, if it has an end. I know here my graph start at this point, right? So this point corresponds to that x right here, you see? It's correspond to that x. So my domain here will start from -5. I know that for sure. This is this -5 right here. And I keep going. All this is covered by the graph, right? Any x here, any x value is covered by the graph, isn't it? Any x here is covered by the graph. And since my graph does not end anywhere, I don't have to say my furthest x is 5. No, it's not 5 because my graph just keeps going forever. Since it keeps going forever, what's going to be the end then? It starts from -5 to what? Since it doesn't end anyway, to infinity, right? That is a domain. This is orange. This is this orange interval from -5 to infinity, right? So now, since we have a closed dot, is -5 included? Should -5 be included or not? The value, the x -5, should it be included or not? What we said? What do we say here? What have we said here?
Yes, it should.
It should be included, right? Exactly. It is a solid dot. To say it is included, we put a bracket. The bracket means the -5 is included. Infinity is not a number. Since infinity is not a number, I have to put parentheses, right? Always. This is a domain. How we get a domain? It is a part of the x-axis that is covered by the graph. That's it. Now the range now is the other way around. The range is the part of the y-axis that can be covered, that is covered by the graph. And how we read the range? From bottom to top. Domain is from left to right. Range is from bottom to top, right? Bottom, what is the minimum? What is the lowest point of the graph? What is the lowest y to the highest y value? Okay. So now let's try together the range now. Since you see, I have to start from the bottom, right? But my graph does not end. You see, my graph goes forever. So what's going to be the lowest y then? It's going to be negative infinity, right? My graph has no end. You see? What is the highest y value covered by the graph? What do you think?
5.
5 is this one right here. This is the highest y value covered by the graph. It's going to be -5. Of course, negative infinity is not a number, so I have to put parentheses. But 5 is a number, and 5 must be included because this point has a closed dot. That's its range. If you have a domain And if you have a graph and we ask you to read the domain and the range, remember the domain is from left to right. The range is from bottom to top, right? Again, these questions, they don't have no calculation. There's no calculation for these questions. We just look at them and we try to answer. So now I'm going to give you another one right here, and then you try to tell me what is the domain, what is the range. Okay, so right here, this function right here, this is a function. From this graph right here, tell me what you think is a domain. I'm going to leave you like a few seconds. Everybody, tell me what you think is a domain from what x to what x, and the range from what y to what y. Go ahead, please. All right. You see, the domain, what do you think is a domain, everybody? From what x to what x?
-3 to 2.
Exactly. You see here, this graph is limited, right? This graph has a starting point and has an end point. This graph has a starting point and has an end point. So it will not be about infinity because it starts somewhere, ends somewhere. Are you exactly right? You said it start at x equal -3, it's end at x equal 2, right? So now don't write it this way. If I write this way, is this an interval? Without parentheses, without bracket, is this an interval? This is not an interval. This is just two numbers. If you write this way, your answer is wrong, right? Everybody.
You need brackets on both ends.
You need brackets or parentheses to say this is an interval. If you write it this way, you are giving me only two numbers. You're not giving me from this to this. If you want to say from this to this, you have to write it as an interval. And the indication of this is an interval is when you put brackets or parentheses, according to the case. Now, -3, should it be included or not included? -3.
Both should be included because they have solid dots.
Okay, I mean, let's see. -3, I agree with you, is included because this is a solid dot, but the 2, I think, I think the 2 is open. Do you agree with me or not?
I can't quite tell.
Okay.
Because of the resolution of the, oh, okay, I see. The line goes through it. That makes it appear
Yeah, the line go through it. Is that, I think the 2 is not included, so you put parentheses like this. If I see that, the range now, you go from bottom to top. Again, don't go from top to bottom. Don't write, the top number and then you write the bottom number. You have to write the bottom number first and the top number last. Okay? What is the bottom y? What is the bottom y?
-5.
-5.
-5. What is the top y?
4.
4. Thank you. Should we include -5?
Yeah.
Yep. Should we include 4?
No.
You see here, that point, of course, is on the graph, right? That point right here, the point right here where 4 exactly is on the graph. So we should include 4. You see here, normally, because of this circle, 0 shouldn't be included, but we have, this is compensated by this one, you see? This part that tell me don't include 0 was compensated by this part that tell me include 0, because it is full. It is, if you don't see no dot, if you don't see no dot at all, that means the point is included, okay? You see, everywhere you see like the solid line, if you see solid line, it means the point should be included. That is the domain and the range. Okay, so when we come back, this is a domain using the graph. We will learn about what is a domain. What is a domain if you have given an expression? For instance, if you say f of x equal to 5 over x minus 3, we ask what is the domain of this? What is the domain of this function right here? 5 over x minus 3, you see? Which means, what are the x's we can plug in and what are the x's we cannot plug in, you see? The domain is all the x's that we can plug in. For instance here, without just even showing you yet, what number you think if we try to plug in that number will run into a problem? What number comes to your mind? When you try to plug in that number, we will have a problem.
3.
Say again?
3.
I think it's 3, right? Try to say f of 3. F of 3 is what? Is 5 over 3 minus 3, right? Which is 5 over 0. Now, is 5 over 0 is 5 over 0 a number? That is not a number, right? That's undefined. You see, which means 3 is not in the domain. Okay? What that means? 3 is not in the domain. Any number that you try to plug in, and then you run into math, you run into a math problem, that number is not in the domain. Okay? And here, I think 3 is going to be the only number that will not be in the domain. We're going to do that next time. We're going to do that Thursday. Meanwhile, your quiz will be open right after class, right? You know, the quiz will be open right after class. So if you go to Brightspace, you're going to see quiz number 3, just like quiz number 1, number 2. You click on the quiz number 3, you're going to get the PDF file. You know, please, when you access the quiz, you have 40 minutes to submit your answer. And believe me, I do check the times. I do. You know, even if I have like, you know, I give everybody the benefits of the doubt, but I do check the times to see if somebody has access to the test now, and then they submit the answer like 2 hours later. You know, that cannot work. So don't access the quiz until you know that you are ready to do it. Okay? Okay, so you have like until Thursday noon, 12 o'clock to submit your answer, just like quiz number 1, number 2. Take it seriously because it does help. It's 5% of the grade. It does help the grade, okay? Not like a test, but it does help. So take it seriously. I hope everybody gonna do a good quiz. You know, everybody did like, I mean, a lot of people did like a good test number 2. I hope now everybody gonna do a good quiz number 3, and then everybody gonna do a good test number 3, okay, which is about to come, and then a good final exam, all right? Thank you, everybody. Don't hesitate if you need help or if you have questions. Thank you, everybody.
Thank you.
Thanks.
Bye-bye.
Thank you.
Bye.